Okay, so welcome back. When we last left off, we were talking about lists, and we've seen a lot of what we can do. They are objects that store multiple items. Um, those items don't have to be of the same data type. They can all be ints or all be strings, or they can be some kind of combination of the data types we've known so far. And pretty much we've talked about them as one straight line, one long pillbox, if you will. Now we're going to talk about two-dimensional lists. We're going to keep going today with two-dimensional lists, tuples, and then using a package called the matplotlib package, as in math plots. Um, and we're going to show how two-dimensional lists or tuples will work in plotting x, y coordinates on various graphs. So let's just jump right in. We've learned about lists. Now, what is a two-dimensional list? Well, it's a list of lists. It's a list that contains other lists as the members of the list. Some people call them a nested list, but basically, the easiest way to think about these are a list of lists, and that list of lists, that two-dimensional list, if you will, is basically like rows and columns. Think of a simple spreadsheet, your Google Docs spreadsheet or Excel, and think about when you work with rows and columns of data. That's kind of how you're going to address a two-dimensional list. And so, in that same respect, when you talk about a spreadsheet, you might say column A, row 1. Okay? Um, and because you need two coordinates to figure out what cell you're talking about, you need the same thing in a two-dimensional list. You need two actual indices, to actually do this, and you can use a nested loop, like we've talked about before, to process these. So what does a two-dimensional list look like? Well, your book likes to use this example of just pairs of names. And I suppose this could be something you might see in the real world if you had a course, for example, where you had to team up with people or have groups, and maybe you have, these 6 people in the class, and group 1 or group 0 in this case might be Joe and Kim, and group 2 would be Sam and Sue, and group 3 would be Kelly and Chris. And that would be nice. And you could have that kind of a relationship between those, so you have a list of lists. Um, More commonly, we talked about this last week, right? We talked about our coffee, and we were doing different how much pounds we had of each brand of coffee, and if we were refilling them, that kind of thing. Um, so again, if you think about this more like a spreadsheet, you'd have a description of the coffee, which was a string, and then a float indicating the value of how many pounds of coffee you might have. And Mocha Java had 20. You had 20 pounds of Mocha Java, and 18.5 pounds of the Colombian, and 50 pounds of the Kona, and that would be, if you will, how you would address these particular lists. It's a list of all the coffee you have, and each element of that list is a list itself, which is a string and a float. So that might be maybe more of a hands-on example. We talked about records and fields. Each one of those cells would be a field. Each one of those rows would be a record. So now how do you address these things? Well, again, by column and by row. So, and you start with, actually, unlike Excel or Google Sheets, you start with actually the row when you're addressing these. So if you have 3 columns and 3 rows, this is how you would look. So this first box up in here would be row 0, column 0. Row 0, column 1, row 0, column 2, etc. all the way across. So again, row 1, column 0, row 1, column 1, row 1, column 2. And this would be pretty much how you address each of these lists. Um, so let's maybe look at an example of where we might actually use this. Do you recall we had this last week as well as one of our examples? And in the example, we talked about how each one of these things was a record. 3 items together was a record: the name, the ID, and the department. So if I launch Python here, we could do something very, very similar. And I actually have this in a window here, so let me just kind of plop this in here, just to make the typing easier and save a little time here. So we could have our record of employees, and those employees, let's make that a little bigger for everybody to see. We know that 3 of these things are one record. So we might have a list of lists. And you see we have this double notation. So our list is delimited by our square brackets. And then each list inside that is also square brackets. So here's 1 list, here's 2 lists, here's 3 lists, all inside our bigger list. And then how would we iterate this? Well, again, for each record in employees. Well, here's employees, and again, employees, this would be the, this would be the first element. This would be the second element, etc. And then in each side of these elements, you have 1, 2, 3. So, if we wanted to iterate through this, just like any other nested loop, we could say something like, for record and employees, so that's one for each one of these in the employees. Let's just start with this. Let me show this. Let's go to here and say, okay, and then we run this. There's our list. So for each one of those, we see a list printed out, right? Now, let me get rid of that. And we'll do this. And again, we have this nested loop here. So now for every time we get one of these lists as a record, we're going to break that down one more time. And we're going to print each field in that record. Or rather, for each one of the elements in this list here, the list inside the list, we want to print the field with tabs separating them, and then we'll print a new line. So what we should then get at this point is now, and this is just for our initial print just to get things rolling here, we have our records all printed out in something a little more of a table that we can very easily understand. So that's kind of how it would go. The book has a rather awful example, if you ask me, but let me see if I can find that one here. We can go to here, chapter 7, and there's a random number. So what the book shows you, as far as multi-dimensional arrays are concerned, is we're going to make this is a program that makes a 2-dimensional list of random numbers. So we have 3 rows and 4 columns, and immediately it initializes it as 3 rows with 4 digits inside each one. And again, you can see this a little better. For a range in rows, and then 4 columns for C's and columns. Basically create a random integer to fill and see this double notation here as far as the row and column is concerned. And again, just to refresh you here, this is kind of what we're looking at. Row 0, column 0, okay, and all we're doing is we're actually extending this so there's 4 columns, so 0, 1, 2, and 3. And when we run this, this is what we end up getting. Row 1, row 2, and then row 3. With column 0, column 1, 2, 3, 4, but 0, 1, 2, and 3. And that is pretty much the concept behind a 2-dimensional list. We're going to be going through these a little more in the coming weeks. In your lab next week, you will be practicing how some of these work and function. But understanding this basic setup here is the most important part right now. It is basically a list of lists, and to address them at least by their indices, you start with row and then column, and literally the 2 square bracket notation right there. So tuples, what's a tuple? A tuple is a immutable sequence. If you remember what we said immutable was, it means you can't change it. So it's a list that once you create, you can't change. The format looks like some name equals, and notice here that it's the same format with the comma in between the values, only this time we're talking about parentheses, not square brackets. And that's an important part because you can actually use parentheses to create a value. So if I start this up here, I can say my tuple equals, and I can say 1, 2, 3. Okay? And that's fine. And I can do the same thing that I can do with a list, print my tuple, and you see, and it puts it in the parentheses, not the square list. However, if you're making a tuple, just call it TT, if you're making it a value of 1, just one element to begin with, okay? Then you just say, 1. You can do that, but what happens is that's not a tuple then. That is actually just a variable. And how do I know this? Well, because when I print it, it prints the word 1 for me. But if I try this, and in my parentheses here I put 1, then a comma, now that becomes a tuple. And how do I know that's a tuple and not a string by itself? Well, because now I can see it's in the notation that indicates a list, a tuple, with the parentheses around it. And I see that with the comma, there's only one thing in this tuple. So just be careful of that. Parentheses are just a grouping thing for everything else in the world. Tuples still use that parentheses notation, but it's still a immutable sequence, if you will. So keep that in mind when you go to create these things, if you're creating a tuple of just one element. So tuples, just like a list, they support all these features. You can do subscripts for retrieving your elements. You have the indexing methods. You have len and min and max. All the same slicing methodology works with the parentheses. There's still something in the tuple. The plus operator, the star operator for duplicating them, all those are the same. They haven't changed. But because you cannot change the values once you create a tuple, then these methods are no longer there. Append, remove, insert, reverse, or sort. You can't change these things. Once you make a tuple, that's it. All your data is in there. You can't sort it. You can't change it. You can't add or remove or replace anything inside there. So then everybody asks, well, then why? Why do we use tuples if we have all these lists and we can do all these other things with a list? Well, there are a few advantages to tuples. And keep in mind what we talked about way back in week 1 about memory and processing cycles. Processing a tuple is much, much, much faster than processing a list because all these other things don't exist and they don't have to actually be. They don't have varying data inside them, right? They don't change. So because they don't change, then it's very easy to work with these in memory if you are the Python interpreter because you know they are effectively a constant. It's kind of like the constant version of a list, but I don't want to go too down that rabbit hole because that's not exactly right either. But it's, if you think about it in that respect, it's something that's not going to change once they're created. Okay? So because of that, tuples are safe, right? You don't have to worry about somebody else overwriting your data. You don't have to worry about a lot of things if that list of that tuple of information cannot change, right? And then as far as that goes, because of the safeness of these, there are actually some operations in Python that require a tuple and not a list, simply because of that. And that's where we use tuples. There is a question on your lab next week about why. What are the benefits of a tuple? They're basically faster to process with and safer because you can't change the data accidentally or on purpose. 2 more functions that your book covers that you really should know about, lists and tuples. There's a function for each one of them. So if I have my tuple here, TT, I can actually use the list command and I can say, we'll just say new list equals list. You see that's blue like a function, TT, meaning I'm going to convert my tuple TT into a list. So now if I print TT, that hasn't changed. If I print new list, you can see it is a list of 1. Conversely, I can say new tuple equals tuple new list, and turn that list right back into a tuple again. So that's it. Just basically like we have int and float to convert things into those respectively, or str for that as well. You have list and tuple to convert a tuple into a list or a list into a tuple respectively. Okay, so moving on to the last thing we have here. Learning how to do plots. Do actual data plots, graphs, line charts, bar charts, pie charts, using data within Python. So one of the things we're going to have to do is use a new library, matplotlib, which is a math library for plotting graphs. Now, again, it does 2D charts and graphs. It is not a standard Python library, meaning you can't just import it. You will have to, import it, but before you import it, you actually have to install it off the internet. So, because it's so not a standard library, it's not even part of the regular Python distribution. Now, this is where things are going to get a little complex. If you've got a Mac or a Linux system, it should be pretty easy. Just use your sudo command, use pip. Pip is the Python installing subprogram that will install libraries such as this. I'll start with the Mac one or Linux because it's pretty easy. Sudo pip3 install matplotlib. Plain and simple. Watch it go, it's all set, and then you'll have to use the import command to do that, and we'll do that shortly. If you're on a Windows machine, and this so depends on if you have Windows 7, Windows 8, Windows 10, Windows is a little more finicky, especially with Windows 10. It wants you to be an administrator, and that is an important part. It's not just like installing software where it asks you and you say okay. You actually have to do quite a little bit. From a command prompt, that's like your DOS prompt, not the Python interpreter prompt. We are not talking about the Python interpreter prompt. And in fact, for Mac and Linux people, that's from your command prompt as well. You open up console if you're on a Mac, you open up any terminal window if you're on Linux, and you run that sudo command. If you're on a Windows machine, you will need to use your command prompt. It looks something like this. And yes, that looks a lot like the Python interactive shell. It is not. It is your Windows system prompt. And you will type pip install matplotlib. Mine's already installed, but as you will see, it goes through. It looks for all those packages. You will see some white bars going back and forth. And hopefully it will install for you. I know we had issues when some people were installing Python before. That's kind of the idea. But again, the whole important part of this is that you need to do it as administrators. Now, to run the command prompt as an administrator, if you're a Windows user, launch your start menu, go down, so go to all programs, go to your Windows system and open up that little subfolder, and then command prompt. But you can't just click it. You have to right click it. The little menu pops up right here, and you will have to say more, and under more another submenu pops up, and you will have to click run as administrator. That is the only way to run this pip command. Okay, one more time, it looks like this. Pip install matplotlib from the Windows command prompt as an administrator. Appendix F in your book has more information about how to use pip, and should help you how to install this as well too. I would ask, please, since so many computers are so different, I'm not a DOS expert, I am not a Windows expert. Please, if you have problems with this, please post it into the Q&A forum. Please try to do this early. There is a question on your lab next week that will use this library. It's simple, it's nothing difficult, but please install this early so if you run into problems, you have time to actually take care of that problem. All right, that said, plotting data with this library, you basically make sure the package is installed. Very simply by importing the library. So I'll bring up my Python window here, and we're just going to type import matplotlib. If you do not get an error, then everything worked just fine. This library contains a module called pyplot. You will need to import that as well. And the book is now showing us, in addition to saying, hey, import this library or this module, you can actually give it a shortcut name. So instead of typing out matplotlib.pyplot. Whatever the function is that we're using, you can actually give it a shortcut name. So we're going to call it PLT. So when we write code for this, that's in fact what we are going to do. Let's see where our first program is here. I'll open this one here. So when you type this in, you're going to type right here, import matplotlib.pyplot as PLT. And then when we start using those commands, we're just going to shorten it to PLT, and that's a neat little shortcut when you import things, when you import modules at least. So I'm going to go through. There's a couple different functions. The plot function. There's a function that shows the actual graph. There's a function that labels all the data labels and all the coordinate labels. So basically, we're just going to go through this, and we're going to say we're going to use a plot function to create a simple line graph that will, effectively just draw whatever data we have. So we have this x coordinates equals 0, 1, 2, 3, 4. The y coordinates equals 0, 3, 1, 5, 2. And as we go through this, you will see we have, I'm just trying to shrink this up a little bit so we can show everybody together here. So the x and y coordinates, if you're going to read them as x comma y, you have 0, 0. Well, that would be, let me get my pointer here. 0, 0 is down here. Then we have 1 comma 3. Here's x is 1 and y is 3. Then we have 2 comma 1 down here, 2 on the x, 1 on the y. Then we have 3 comma 5. And then we have 4 comma 2. And those are our plot points. Okay? And so when you go through this, there's a program in your book, program 719 as the examples go, in the very last section of chapter 7. It's a very simple set of commands here. Again, you import your library and you give it the shortcut name PLT. And your main function here, all we're going to do is just give it some x coordinates. Again, these are a simple list of x coordinates and a simple list of y coordinates. Plot plt.plot, give it the x coordinates and the y coordinates. And because it understands the array syntax, the list syntax, when you give it this command, it'll just know that and know where the data points are. And then you say plot.show, plot.show. And that's it. That draws this neat little line graph for us. There's other things you can do. You can change the upper and lower limits with these commands, xlim and ylim. And then you give it a range, 1 to 100 in this case for the xmin and xmax. So again, plot.xlim, and then 2 parameters, xmin equals 1, xmax equals 100, and the same thing for y. In this case, 10 and 50 to change your x and y axis, respectively. And pretty much, that's the whole thing. You can put little tick marks at various plot points. And so across the x-axis, you can say instead of 0, 1, 2, 3, 4, you can give it dates. You can do all kinds of different arguments, and the chapter 7 spits it out pretty extensively for you what some of these look like. I'm going to actually show another example right now, and this is the one that I had before. It kind of shows you all the examples that you can go through and all the different extras you can put in a plot. So you have your x coordinates and y coordinates. This will not change. Again, we've imported this plot library. Okay. Then we have build the plot with the different coordinates. Marker equals O. That's a new one. We're going to see a little O marker. Add the title, just the title. Just if you've worked with graphs in Excel or in Google Sheets, very similar kind of thing. Title of the graph. Labels on the axis, year and sales in terms of millions in this case, because we have the years across the x-axis, and then we have 0 million, 1 million, 2 million, 3 million, whatever. And you see these are literal strings here, okay? For the y-axis, that would be going up and down. Add a grid, so you can actually make the little grid marks inside there. Display the line graph, plot.show, and then call your main function. So, again, let's pull up our shell here and just open this back up again here. I believe it was this one. Here's our tick marks. Here's our, just turn the pointer off here. Here's our tick marks. Here's our label for the top. We added a grid. You see it's a Boolean that you pass to it, yes or no, true or false, basically. And again, when we execute this, our graph pulls up over here. And as you can see, let's just rearrange these a bit here. It actually creates a new window, brings up this great little graph here for us. And you can see, again, our coordinates, 0, 0, 1, 3, 2, 1, 3, 5, 4, 2. The O makes this filled in circle for us, which is different than our previous one. We see our x-axis now has our labels over here, the years. Our y-axis has the literal strings here for 0 million, 1 million, 2 million, etc. And our grid, we see this thin lit out grid here that, just helps us visualize the lines a little better. And again, all that from creating, using this PyPlot module from matplotlib. And again, that's what it looks like. So there's also a bar chart you can use. So instead of saying plot.show, you say plot.bar. It needs a list of x coordinates, needs a list of y coordinates. So it looks something like this. This would be kind of the code you would write. You could also, there's options then as well to increase the width of the bar. So you see here we have a variable for bar width that we kind of put in here with the plot.bar command. Again, previously the plot.bar has left edges and heights. That would be your x-axis and y-axis. And then you can add bar width to just show them a little thicker. So let's look at one of these here. Open this up. Let's see. Bar chart. Looks a lot like this. So again, we have left edges and heights. Bar width of 10. Plot the bar out with different colors. We'll show that in a second. Sales by year, so we can get a title on this. This graph here doesn't really have a title on it or any other markings, so we can put a title on it. Same variable, same property as we had for the line graph. X and Y labels, same thing. Tick marks at different intervals, and the labels for them. Plot.show will actually execute that and make us create this cool bar. So again, here is our completed graph with all these different colors. Okay. And maybe the white wasn't a good idea here with the background being white. So how about we change that M for magenta. I will close this up. We will save this and rerun it. And lo and behold, there's our new plot. So again, you see, if we go through, we have red, green, blue, magenta, and K for black. Red, green, blue, magenta, black. We have our year down here. You can't see where I'm pointing to. My mouse isn't on. And then the sales going up and down on the y-axis. Again, really all we're doing, these are just more commands to learn. Plot the type of graph, plot title, X and Y labels, tick marks, and plot.show will actually display this graph up here. Colors for the bar chart. More parameters here. Each one has a color. Its color equals whatever, and it has these letters to designate those corresponding colors. So if you can pass a tuple of colors, which is what we just did there. Let's bring that code back up here. As you can see, color is a tuple. This is one of those functions that requires the tuple to be used. And the tuple is simply the list of the colors we want to use. Can we use the same color? We certainly could. Oops, that was the wrong choice. If we wanted them all to be the same color, absolutely. I wouldn't necessarily recommend it. Now it looks like we have these weird looking steps. But again, you get the idea. And if you were looking at different color years, same kind of concept. You'd really want to make sure that they stood out and you could see the difference between them all. Okay. So that's plotting a bar chart. There's one more chart left, essentially, and that is a pie chart. A pie chart is the circular one. I think you're all familiar with them. You basically call the plot.py function. And then this is a little different. The sum of all the values. So you're going to pass it a list. Whatever those values in that list add up to is going to be what the whole of the pie is. And each element will be a slice correlating to that percentage point, since that's what a pie chart is. So for example, if you pass the values 20, 60, 80, and 40, and you plot that out, this is what you would get. Okay, 20 here in the dark blue, 40 in the cyan color blue, the 60 would probably be the green, and the 80 would probably be represented there by the red. So looks like that. There are labels as well that you can add. There's an argument you can pass to give it certain labels as strings. So as you see, we'll call the function slice labels. Here's our list of all the different variables. You can know it's a list because it's got the square brackets. So we got the sales, we got sales labels. We have our function to create a pie graph with a title, and then we're just going to hit show. So these look like this. Let's find our shell here. Open another one here. I did not want bar. Pie chart 2. So again, we're importing our library and our module. We have our list of sales. We have our list of labels. We're creating a pie chart based on the sales data, with our labels being this list here. We're going to give it a title of sales by quarter and hit the command that shows it. And this is what we're looking like. Okay, and again, just like with the bar chart, you can set the colors to whatever you want using the same kind of color schemes. Plot.py, values, colors equals, and here's your tuple for the colors. That's it. There will be one question on your lab next week that will require you to plot out some graphs. Those are the three main types: line, bar, and pie charts. We are not, and you can tell I haven't emphasized a lot with this. There's not much to this. It's a great language, though. Python's a great language for working with data and data at scale. And many times when you want to visualize that data, a quick graph is a great way of doing that. So showing the progress of something would be great. In my day job, working 9 to 5, I work a lot with website analytics, looking at traffic that came in from various sources, and we can plot different points, pulling that data from log files, manipulating that data, and working it into lists and tuples, so we can show this traffic came from Google, this traffic came from somewhere else, this traffic came from people typing it in, whatever the case might be, and plot those out on graphs. And Pi is a great language for reading files, working with the data, putting them into lists or tuples, and then plotting those out in various types of graph. So we covered a lot. There was 2 different videos, obviously, for this lecture. Definitely go through this, work with your lists, work with your tuples, understand which one is which. Again, as always, if you have any questions, please ask in the Q&A forum, or anything of an urgent nature in the email forum. via email to me. And again, I will stress before this lab starts next week, please do not run out of time. Please try to install the library modules in your Python instance, especially if you're using a Windows computer. It can get a little tricky. With that, I hope you all have a great week ahead, and we'll talk to you next time.